Greetings yet again and welcome to another general lectures. Now, um, you guys remember that one guy that talks about fucking around and then finding out, and he drew a graph that is proportional. So he shows that, or he's telling us that fucking around is directly proportional to finding out. Where alpha here is our proportionality constant, and he shows that fucking around, well, alpha is equal to 1, and that gives us a linear graph such that when we find out, we get a proportional amount, or basically the same amount of fucking around, or if we fuck around, we get the same amount of finding out. So if we fuck around twice, we find out double what we expected. Or if we fuck around once, we find out, just regularly find out. And this is a sound thing, but the thing is, sometimes there are certain situations wherein we fuck around and we end up with something, we fuck around and we find out something that is less than what we expected, or that's more than what we expected. So what I'm basically saying is that in real life, or in reality, the graph that we're dealing with that tells us the relation between fucking around and finding out is much different than the guy initially tells us. So what I propose are a bunch of other ways we can, relate finding out and fucking around. So basically now, what we can do is express, let's say that fucking around is equal to x, or the quantity of fucking around is represented by x, and let's say that the quantity finding out is represented by y. So the quantity of finding out is represented by y. Now we can say that y is equal to a function of x, right? And so we can think of that, we can think of y as a map from the space containing x to that same space. If we think in terms of elementary stuff, we can maybe say that y maps R onto R. But let's assume first that both these two are elements of R. Then we say that y now maps R onto R. Alright. So we only fuck around. We have only one input of fucking around, and we have one input, exactly one output, of finding out. Now this is just an abstraction. We can best think of it as a graph, like I showed a while ago. Okay. So how other ways can we relate y and x? Now there are many different types of functions that we can do. So the one that I showed you a while ago, the guy just showed this type of function wherein the slope is exactly a 45-degree inclination with respect to the horizontal. This is x, which is the horizontal. If it's a 45-degree angle, or if this graph forms a 45-degree angle with respect to x, and also exactly a 45-degree angle with respect to the vertical, or y, we also call this OX, and we also call this OY, OX. So if it forms this, our graph is linear. Alright, it's linear, and we get a proportionally constant of alpha, or just 1. Sorry if my birds are screeching. So when we fuck around, we get exactly the same amount of finding out about something. Right? But the next thing that we want to do, okay, so this graph is represented by the function or the formula, because the best way to describe graphs or mappings between two sets is via a function, and function is expressed as y is equal to, wait, hold on. It's expressed as y is equal to f of x is equal to x. So the output is the same as the input. So the y is the same as the x. So at 1, the y value is 1. And at 2, the y value is 2. At pi, the y value is pi. At e, the y value is e. That's what we mean by this. So another function here that is non-linear this time, which I think is the most accurate way of describing the relation between fucking around and finding out, is this function. Y equals f of x equals x squared. This over here is called a quadratic function. So this time, instead of just finding out x here, or well, what we can think of this as x plus some arbitrary value a, where a is the starting finding out. So if our finding out, if at 0 or if at the first instant we're in we fuck around, which is we don't fuck around at all, we find out that, you know, well, you find out something, even though you don't fuck around, you know that this guy is not to be messed with, right? But notice that this has a bigger effect on this, even though at 0, this has nothing, because 0 squared is 0. Okay? So notice though that when we take a small step, like 0.0001, let's say x is equal to 0.001, we notice now, it's still the same, let's say it's 002. We notice that we have a bigger step in the y direction. Y is 0.004. So exponentiation has a bigger effect and gives us a graph that's more potent and it gives us more exponential growth type thing. So because the world is full of hateful people, we realize that, or with very serious people or people that you shouldn't fuck around with, we realize that when we fuck around even just a little bit, we find out more than what we expected, or we get fucked with more than what we expected. So that's why this is a better model than the linear graph that the guy in that one video said. Okay, so how do we graph this? Well, the best way to graph these non-linear graphs is to pick a sample points, a bunch of sample points, and then let's graph it at those points. So let's start with drawing the y axis, y, x, and let's pick some sample points. So let's pick, let's make some tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so at 1, notice 1 squared, so I'll write it up here. Y equals x squared. So the y value, the corresponding y value of a given x value is given by this formula over here, which is x squared, which we just square that x value. So at 1, our corresponding value is y. At 2, our next value is 4, because 2 squared is 4. At 3, our next value is 9. So around here. And as you can notice, this graph here blows up really fast, because once we get to 4, we have 16, which is already beyond the scope of what we're drawing here. So instead of writing this sort of very sketchy graph, let's smooth it out. There. And this is our quadratic function. Now, of course, you can add a constant here, which that would just shift the graph upwards. Now, if we add a value to the x here, so let's say y equals x plus a squared plus b, then a here will shift the graph to the right by a units. So let's say a is 2 over here, then this bottom part of the graph, well, let's say that we have a minus ox, this would extend like this also, because a negative number times itself would give us a positive number or positive integer. Let's work with the integers right now. Okay, so if we add this a directly to the x value and input it into the function itself, then we would be shifting this origin, which is at 0, to a. Well, let's say a is 2, as I said a while ago. It would instead be over here at this point, so it would go like this. Now, if we add a like this outside the function, then we would make the function jump up by a unit, so it would be over here. Okay. So we notice that when we fuck around twice, we end up finding out 4 times than we initially found out. So this, again, as I said, this is a very potent way of describing the relation between fucking around and finding out, especially in today's society, with a lot of very angry people and frankly very detestable people as well. So yeah, there are other ways of describing or relating fucking around and finding out. Well, there's also the very peculiar way of describing it via an asymptotic function like 1 over x. Okay, so actually 1 over x is one of the best functions of describing or relating inverseness between fucking around and finding out. So 1 over x, of course, is another map like the others, and y equals 1 over x. Now you notice that if x is 0, this doesn't make sense because it blows up directly to infinity. So let's graph it. I'm gonna say the absolute value of x, because if you say regular x, this part here goes to minus infinity and this part goes to positive infinity. If we say the absolute value of x, then both these guys go off to infinity. So okay, you notice that, alright, this is 0, the origin. This up here, you notice that this graph never touches the x-axis or the y-axis or the finding out axis. And neither does it cross the fucking around axis. It has no origin. But suppose we start somewhere over here, say at 1. So our output is 1, of course. Okay, once we're at 1, right, we get 1. So when we find out, when we fuck around once, we find out once. Okay, so let's suppose that we want to get closer and closer to 0. Let's fuck around less, right? And see what happens. You may notice that when you fuck around less, what you're finding out increases exponentially. So you find out more and more and more the less that you find out, or the less that you fuck around. And in fact, I believe this is what happens to people who wait. So this is a great this is a great mathematical way of modeling patience, because as we all know, good things comes to those who wait. So the more we don't fuck around and ergo not, be impatient and ergo wait, the more good things come to us and the more we find out or ergo get good things. So, but if we're talking in terms of, fucking around and finding out, this is a very weird graph, and actually really the best one among them all, in my opinion, is the quadratic one. So another weird graph that we can use to describe the relation between fucking around and finding out is trigonometric functions. And trigonometric functions are basically functions that we use to describe points around a unit circle. Or they're the wavy type things that you see in physics, like say modeling the look and the structure of a photon. So these look like this. So this is an example of what is a sine wave. So y now is equal to sine of x. And if we let the root here, or the part where it crosses the x-axis, be pi, x here is expressed in radians. Because at pi radians, sine is 0. And at sine pi over 2 radians, we get 1. of course, the sign is not even compared to cosine. So at minus pi 1/2, sine of x is minus 1. And at pi, of course, pi sine of x is pretty much the same thing, except minus pi over 2 is reversed, or the output for minus pi over 2 is reversed. Or actually the output of pi over 2, or the output of x at minus pi over 2 is just the additive inverse of the output of this pi over 2 in sine x. Now cosine x is the same here, except we just shift the graph such that pi over 2, or the sine of pi over 2, is 1 over here. So at 0 or sine 0, it's 1. So the output is 1, or 1. So notice that the range of sine is always from minus 1 to positive 1. It never exceeds those two values. So you can say that for this function, x and minus x, 1 and minus 1 are the maxima and the minima of this function. So maximum of the minimum of the function, or of the range for this function. Or as we call it, the image of the function, because the image is the set of all outputs that you put into this one. Okay, so it's best to say, well, it's the maxima and minima of the image of this function. Okay, so this is a bit strange, because if we fuck around once, we notice that we don't find out anything. It's strange. And then notice that when we take half a step from that, so if we find out, or if we fuck around 1.5 times, or 1 added to 1/2 amount of times we fuck around, whatever the hell that means, we end up, or if we fuck around half of the way, so let's say we're fucking around and then we stop in the middle, we end up finding out less than what we anticipated. Okay, and also notice here that when we fuck around and then stop fucking around, in the middle, we end up finding out once. Only once. When we fuck around fully, like we fuck around fully once, 1 unit, we end up knowing nothing. And same thing, when we fuck around twice, 2 pi times, whatever the hell that means, we end up knowing nothing. And notice that if we plan to fuck around, but it hasn't happened yet, if we plan to fuck around half of the way, so if we were thinking, oh, I want to fuck around, and then you stop halfway through that thought, we end up doing less, or finding out less of what we expected. In fact, we have a debt of finding out. So that person that we plan to fuck around with owes us a beating, or they owe us at least 1 ounce or 1 unit of finding out. So they owe us, or they owe us just because we're thinking halfway through, I want to fuck around to find out about something about this guy. And then the same thing applies when we fuck around only, or if we think about fucking around, or if we plan on fucking around fully, we get nothing. I mean, obviously we get nothing. In fact, this is the one that makes the most sense here. Or actually, because it's minus here, or it's simply 0, yeah, we find out nothing. And this is the only part of this entire graph that makes freaking sense. And also the part where if we don't do anything, of course, we don't get anything. So yeah, 0 here makes sense. And this part here, this input here, minus pi, is the only one that makes sense, because when we think about fucking around fully and not halfway through, then we don't get anything, because we don't actually act on that thought of fucking around. And then so now it still doesn't make sense, because this entire part of the graph should give us nothing. This should be 0. It should just be nothing. Like, there shouldn't be any graph here, because when we just think about things, they don't actually come to fruition until we act on them. And because negative part here is not an actual value, what we want to think about negative values here in this case is us thinking about fucking around, us getting to the point of fucking around, Because here, at a slight nudge in the positive direction from the origin, that's when we begin fucking around. Okay? So when we take a small step to the left, what we're doing is thinking in reverse about fucking around. So let's say you want to rob a house, right? Because of this blind guy that you think is so vulnerable, you can steal from him. This is definitely not a reference to a horror movie. In reverse, like thinking the plan from backwards. So from the end, wherein you get the money and then going backwards to when you break into the house, that's essentially traveling this way. And when you actually do the plan, when you do break into the house, like starting with breaking into the house silently and then ending with exiting the house without the guy knowing, with you having the money all in the bag, that's when you travel along this part of the interval. When you travel in the positive direction. So it's still a bit strange, this function in describing the relation between fucking around and finding out. But another thing that's pretty odd, a pretty odd function that we can use to describe a relationship between fucking around and finding out. In fact, there's an infinite amount of functions that we can use to describe between fucking around and finding out. So this third function, or this third type of function, is frankly the reverse of the exponential, but it's closely related to it. And this function is e to the x, or what we call exp of x. And the graph of this is almost like an exponential function. But notice, this is what it looks like. There. So e to the 0 is just 1. So I'll just move that over there like that. Okay. So this is 1. And then notice that for bigger and bigger values of this blows up to infinity. So really, this is a slow but sure exponential growth. It's not as powerful as x to the n, but it is surely just in the ballpark of being powerful enough to model, societal stuff. So let's say that you want to fuck around with a very buff guy, like a very strong muscle guy, and then he's very chill. He's a very chill guy, right? But you still want to fuck around with him. You still want to know about his love life. You want to steal his girlfriend or his boyfriend, whatever. And let's say that this models his behavior. Now, if you take a small step, like if you don't even fuck around, you notice that this guy doesn't want his life to be fucked around with, right? He doesn't want anyone snooping in on his business. None of us want anyone snooping in on our business, right? So even if you're just starting, or even if you're still in the middle of thinking about fucking around with him and actually doing the thing and fucking around with him, he's already thinking about plans to break your neck. Because he doesn't want you to fuck around with his life. So that's why here, at point 0, wherein you're in the middle of thinking about fucking up and planning around fucking around with his life and actually doing it, he's already planning stuff. He's already over here. His suspicion of you, or what you're gonna find out about him, even though you haven't even done anything or thought about anything, is already given to you. He's gonna tell you, hey bud, I'm a chill guy, but if you fuck around with my life, I'm gonna fuck you up. That is exactly what I'm saying here, or that is exactly what this model is saying here. You've already found out. In fact, this guy has given us what we call boundary conditions for, let's say, a differential equation that we want to solve using this. Like, let's say d over dx, or dy over dx is equal to y. Let's say that this differential equation models that guy's behavior. Then we already know. The guy tells us, hey, at x equals 0, so if you don't fuck around, if you're in the middle of planning to fuck around with my life and in the middle of, going ahead and fucking around with my life, my y, or the thing you want to know about me, is exactly 1. So you find out exactly one piece of me, and that is, I don't want you snooping in around and fucking around with me in my life. So that's exactly what we're saying here, and this solves this condition, this boundary condition for this differential equation. Okay. So this is just a snippet of all the other possible functions that we can use to describe the relation between fucking around and finding out, of course. Now, we can talk about the concept of a derivative over here. And so what the derivative is basically how much you're finding out at the certain moment in time when you fuck around. So let's say I have a graph here of, relation between, of course, your x value is, your input is you fucking around, and your output is you finding out. Let's say I want to find out how much I'm gonna know, or the rate of change that or rather, the amount of change that's happening in what I'm knowing as I take a small, tiny, but non-zero change in what I'm doing in fucking around. So I want to know how much what I'm knowing is changing with respect to how much I'm fucking around. Or with respect to the change in me fucking around. That's what I want to know. And that is given through the derivative. So this f of x here, or this y, this over here, this tangent line, which is this is actually a local maximum, so it's flat, tells us the slope of this line this barely touching the graph, only at one point. That's what we call a tangent line. The slope of the tangent line, okay? And okay, so the derivative, which is equal to the slope at x, gives us the change in the dy over dx, the rise over run, the dy, which is the change in finding out, and divided by the change in fucking around. That's the derivative, or the slope. And for this given function here that relates our, fucking around and finding out, the derivative is the limit as h approaches 0 of the function, or plug h into our, finding out function, x plus h, and then subtract by the amount we fuck around at the point x, or the amount of what we find out at point x, divided by h. So what we're saying is take a small step, or at a point x, let's fuck around just a little bit. Alright, ignore this limit over here for a while. Ignore it. Think about this function for a while. Okay, let's take a small step in the fucking around. Let's fuck around a little. We get a corresponding change in finding out when we fuck around even just a little bit. It could be like 0.001, 0.0000000 pi, 0.000000001. It could be 0 times 10, it could be 0.1 times 10 to the minus 1 million. It can be that much. As long as it's not 0, the derivative will exist. Okay, so when we do take our step in the x direction, or when we do take a step in finding out, we take a corresponding step in the direction of finding out, fucking around, and then take a step in the finding out direction. So this f of x here, we subtract it from this because what we want to find out is just the input. We can just put f of h, right? Because sometimes it would make it vanish and become 0 over 0, which does not make sense, and is an indeterminate form. So the best way we can do it to avoid getting 0 over 0s is to do this formula over here. Okay, so let's say that the person that I'm fucking around with has a graph, or has a function that describes, the relation between me fucking around with his life and him, giving me a piece of his mind. Let's say it's described via the function x squared. Okay? Let's say it's described by the function x squared. Now, I want to know if I fuck around twice, what is the rate of change of, me finding out with respect to me fucking around at that point. So basically, how much is changing in what I know with respect to what I fucked around with, or in the change, or a corresponding change of me fucking around. Okay, let's use this formula. So I'm just gonna write down here d over dx of f of x. Okay, let's say equals x squared. Now we just plug it into here. So the limit of h approaches 0, as h approaches 0, of f of x plus h. So since f of x is x squared, that gives us x plus h squared minus x squared over h. Now expand this to get the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared over h. Now notice that this minus x squared eliminates with this x squared, so that vanishes off and gives us the limit as h approaches 0 of 2xh plus h squared over h. Divide h to get the final limit. Limit as h approaches 0 of 2xh, 2x plus h. And because we're getting closer and closer to 0, what we want to know is what happens at that point. So what the value doesn't exceed here is precisely 2x. So our derivative is 2x. And we find out, okay, so I fuck around. So the final answer is I fuck around twice to find out, to see, I fuck around twice to see I fuck around twice to see that I get 4. So quadruple the times I fuck around, or I find out. So we get 4 times what we anticipated with respect to some minuscule change at h. So we get the slope, and the slope is exactly 4 at 2. And so we get, so the unit for this is 4 change in finding out over per change in fucking around. And that's a good place to stop.